Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin our 64th and first CoCoRaHS Weather Talk webinar of the new year. Thanks for joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we're recording today's talk, and it'll be available later this week on our website. Today, we're going to be talking about winter weather, climate, and snow. We're very fortunate to have with us Elizabeth Burakowski, Research Associate Professor at the University of New Hampshire. Liz's work focuses primarily on winter climate change in the northeastern United States. She grew up in New Hampshire and has been enjoying skiing, riding, and winter for 30 years. Liz spends a good amount of her time with New Hampshire educators and their students, teaching them how to track changes in winter climate in their own schoolyards. Well, welcome, Liz. It's great to have you with us today. I'm going to ask you a question we ask many of our guest speakers, and that would be, how did you know, or how did you begin in your profession? How did you know you wanted to be involved with climate?
And Liz, I think you're still muted, actually.
Okay, we're having... There we go. Great.
Technical difficulty. Now it's fixed. Yeah, so I think my journey in adventuring with snow started very early, probably actually shortly after this photo was taken. So this is, I was about 3 years old in this photo. It was 1984 in Waukesha, Wisconsin. Shortly after this photo was taken, we did move east to New Hampshire. And you can tell which one is me because I'm the one with the dimples. If you've ever seen a picture of me, you'll know I look a little bit more older now and have some dimples. And I also started skiing shortly after that photo was taken. So you'll see skiing show up pretty frequently throughout this talk, sprinkled in here and there. I started skiing around 1988 at a small resort in South Pomfret, Vermont called Ski Suicide 6. This resort is one of the longest running resorts in the North America, I believe. Their first lift was installed in the early 1930s, and they're still running today. I quickly moved on to learning how to go to a ski club. This is in Manchester, New Hampshire. If anyone knows Manchester, New Hampshire, it's our queen city. It's much larger than the state capital and home to one of the smallest resorts in New Hampshire. McIntyre has about 6 or 7 trails when I was there. It's expanded a little bit since then. And fun fact about Manchester, my twin sister used to be the Leslie Knope, so she worked in Parks and Rec. And she had the inside scoop on this resort. And basically, this resort does not earn a lot of money. In fact, it's usually in the red year after year. But the city subsidizes this resort for a very good reason. It's the home of many skiers and where they learn to grow their love for the sport, which benefits the state in a much bigger way later on when they grow up to be full-time skiers at our much larger resort. So you can consider it a feeder resort, if you will. In 1993, I learned to snowboard at Pat's Peak, and this resort is also one of the longest family-owned resorts in New Hampshire. This one is near and dear to my heart, but the last time I was there was not necessarily for skiing and riding. It was actually for a beautiful fall wedding, and that's going to come up a little bit later in the talk when I talk about the societal impacts of warming winters and how ski industries are responding to a warming climate and adapting. Unfortunately, those 3 resorts, they've managed to survive, but there's been 600 other ski areas across the Northeast and beyond that have closed. If you go to the New England Lost Ski Areas Project, you could probably find some of your old favorites from back in the day that may have shut down, like this one here. This is Maple Valley in Vermont, and it's been closed since about the year 2000. Last time I was there was, I think, around the year 2009, 2010. And everything was still in the ski shop. All the trophies were still on the shelves. And they also still had a Happy New Year 2000 on the whiteboard. It's still for sale. I think you can buy it for just under $1 million if you have the cash lying around. But just keep in mind that this is a lower elevation resort, and it's also in southern Vermont and faces bigger challenges than our more northerly and higher elevation resorts. Many of the resorts that closed had different reasons. Some couldn't compete with the big guys down the road. Some chose not to invest in the 1970s in snowmaking technology. But behind a lot of them and underlying their demise had to do with temperature. Looking at annual temperatures across the globe, you can see in this graph, starting in around 1880 through the 1940s, we were below average. Anything below that zero line indicates that the global annual temperature was colder than normal. In this case, we're looking at this relative to the 1951 to 1980 average. So think in this period here where things are looking pretty neutral. After the late 1970s, however, you see a very distinct trend, and temperatures began increasing, and quite a bit. I myself, I was born in 1981, and I've not lived a single year on this planet Earth where the temperature has been colder than average. And I suspect many of you may have experienced the same, and if not you, probably your children. We can also look at this type of graph in a much more exciting way, a movie map. This is one of my favorite maps to show people that are learning about climate change and global warming. And this one is showing temperature changes across the globe. Again, starting in 1980, anywhere you're seeing a blue color, that means it's colder than average, and a darker blue indicates much colder. So this region up here in Greenland and northern Canada was probably on the order of 2 to 3 degrees colder than average. Anywhere you're seeing these dark red spots, well, that means it's warmer than average, and a really dark red means upwards of 2 degrees Celsius warmer than average. So I'm going to play the movie and narrate it as it goes along, and you'll be able to see some changes as these blobby colors start moving around. So let's take a look. You'll note most of the map in the early 1880s is very blue. That means the Earth itself was colder than average. As we get into the 1930s, you're going to see the US light up in red. So let's watch that happen. There it goes. That's the Dust Bowl. This is a period of excessive warmth and drought. In the 1960s, a new pattern emerges, especially in the eastern US. We get a flash of blue there. A lot of that was leading up to the Clean Air Act, and that removed sulfate particles from the atmosphere from the burning of coal. We had stricter restrictions on those emissions. By the end of the century, we start seeing a very distinct pattern, and into the 2000s, now we're seeing a lot of the warming up north, specifically in the Arctic. You'll note that very few places on Earth are showing colder than average temperatures now. Just about the entire Earth is showing up in red and in light colored yellows and oranges. The pattern that we see up in the northern part of our globe is also related to sea ice. Sea ice, it turns out, is very reflective. This is one of the questions I had asked you all. So which reflects more, snow or not snow? Snow actually is a very good reflector. It's one of nature's best reflectors, and it reflects much of the sun's incoming solar energy. Darker surfaces, like the ocean water here, are going to be absorbing a lot more of the sun's energy, and those are going to heat up in response to that. So this too is a movie map. It doesn't start in 1880. Unfortunately, we did not have satellites launched at that point, but they were launched right around 1979 to start tracking sea ice. So we can watch this one play as well. And I can literally say, when I was growing up, Arctic sea ice filled the entire Arctic Ocean basin. You can see that here. Much of the time it is hugged up right against the coastline to many of the continents that border the Arctic Ocean. As we get into the 2000s, again, another pattern starts to emerge. Specifically 2007, right there, was a really bad year for sea ice. And again in 2016, right here. 2017 wasn't much of a recovery, nor was 2018. The trend has continued to reduce sea ice in the Arctic, specifically in summer and early fall. And this has led to more energy being absorbed in the northern latitudes. But it's not just sea ice. It's also having to do a lot with snow cover. Another question I'd asked you is whether the snow cover extent in the northern hemisphere had decreased, stayed the same, or increased. And from this graph from the Rutgers Global Snow Lab, we can tell from here that things are pretty much on the decline for spring northern hemisphere snow cover extent. If you look at regions, especially 2016, that was a particularly bad year for snow cover in the northern hemisphere. And again, when you remove that highly reflective snow cover, that too is going to lead to the increased absorbed solar radiation from the sun on the ground surface, and it accelerates warming through what's known as the snow albedo feedback. But the Arctic isn't just symptomatic of changes that are going on in northern latitudes. We also have a saying that's what happens in the Arctic does not necessarily stay in the Arctic. There was recently a paper published in Nature Communications that illustrated that warm Arctic episodes, specifically during times when you have Greenland above freezing, were linked with increased frequency of extreme winter weather in the northeastern United States, or in the United States in general. So if you feel like things have been getting kind of winter wacky weather, you might be onto something and you might be feeling the effects of these warm winter Arctic episodes. Well, let's focus in on winter climate and specifically in the northeastern, or in the eastern US. I'm so used to saying northeastern because I'm a northeastern researcher. What we're showing here is the change in temperature since 1970. If you take a look at the bar graph, right, anything that's in white or blues, that's showing a cooling temperature, and everything that's in reds is showing a warming temperature. What we can see from this map is that there are no places in the United States that are immune to warming. Everywhere is warming, and hotspots include both New England and the Midwestern United States. Again, some of this is tied to our loss of snow cover. We have some other symptoms of climate change, especially in the northeastern United States. Those who are from the region, especially from New Hampshire, might recognize this lake as Lake Winnipesaukee. This is our largest lake in the state of New Hampshire, and also home to a lot of ice fishing. When you take a look at the state, right, this is right here in the middle, the definition of ice out has been kept track of in Winnipesaukee for the last about 120 or so years, and since the late 1800s, and it's defined as when this beautiful vessel, the Mount Washington, a nice paddle boat, can make its way to each of its 5 ports on the lake. So once the ice out is declared, then boats are free to go around the lake. When we look at this graphically, we can see on the y-axis here, this is the number of days past January 1st. So day 90 or so is about the end of March, and day 120 would be somewhere around the end of April. Note, there were some years when it was even into May when we started to see ice out in Winnipesaukee. However, recent years, we've actually had some years when it's iced out even in mid-March. And this has really put a damper on a lot of activities that go on the lake, including ice fishing and snowmobiling. If you note this photo, this is my mom in 1967. She's actually not at Winnipesaukee when this photo was taken. She was ice fishing in New Jersey, which it still does have some ice fishing now and again. It's actually not as common as it was in the 1960s. Having a winter that's enough to support ice and snow on a lake in New Jersey is becoming much more rare. And this is kind of problematic because ice fishing folks spend quite a bit of money on ice fishing equipment, to the tune of about $240 million each year, according to the American Sport Fishing Association in 2013. So this is not just a symptom of climate change, but also a symptom of economic change as well. We've had other winter climate indicators, mostly across the US. They include fewer days with snow cover. Here in the northeastern United States, we experience about 1 to 2 fewer weeks of snow cover than we did in the 1960s and 70s. So that's over within most of our lifetimes. And we've also experienced earlier spring melts, or rivers, lakes, and streams are all icing out about 1 to 2 weeks earlier too. And more importantly, we're also seeing less snow and more rain. Our rain to total precipitation rate, or snow to total precipitation ratio in winter is changing substantially, and that means more rain on snow events. This can really affect hydrology in regions, especially if ground soils are frozen, because ground soil starts acting, or frozen soil starts acting like an impermeable surface, like pavement, and can lead to a lot of runoff into our rivers, lakes, and streams. Driving this trend, of course, is the increasing levels of carbon dioxide in our atmosphere, specifically from the burning of fossil fuels. When we started keeping track of CO2 in the atmosphere up at Mauna Loa Observatory in Hawaii, we were looking at around 310 parts per million. By the time I learned to ski at Suicide 6 in the 1980s, we were up to 351 parts per million. When I learned to snowboard, we had increased by another 9 parts per million, up to 360. And when I started taking classes at the University of New Hampshire to earn my PhD and my master's degree, the number I had to memorize for my exam was 380 parts per million. Today, I teach at the University of New Hampshire, and my students, for their exam that they took in December, the number they had to remember was 410 parts per million. And it's pretty obvious to see where all of this is going. We're going to continue to see increases unless action is taken to reduce CO2 in the atmosphere, and specifically to reduce emissions of CO2 into the atmosphere. Scientists have looked at these projections, as we call them, and we know that they're going to continue to increase. When will they start to decrease depends on how we act. If you look at this green line here, this is a representative concentration pathway, just essentially a fancy scientific word for a scenario in which we reduce emissions. We could see that CO2 might level off at just above 400 parts per million, which would be great news for our environment and our ecosystems. We could start seeing some real change to slow our warming trend. If we continue emitting fossil fuels, however, and follow this blue line instead, we could see CO2 concentrations upwards of 900 parts per million. And this would be pretty catastrophic for our environments. We would start to see much more extreme heat. We would start to see many fewer days with snow cover. And we would also start to see huge changes in winter, such that it starts to look much more like spring. We can look at the temperature change globally. If you follow, again, that higher emission scenario or business as usual, we could expect to see globally a temperature change of about 8 to 10 degrees Fahrenheit. If you follow a lower emission scenario, we could limit it to about 2 degrees Fahrenheit. And to put this into perspective, we already have warmed about 1.8 degrees Fahrenheit. So I don't know about you all, but I'd much rather stay in this range down here rather than explore this range up here. We've done this sort of analysis for the northeastern United States specifically, and this graph is showing our annual maximum temperature. So in black, this thick black line, we're showing our observations. In the thin gray line behind it, we've used a model to simulate temperatures, and it's just a single model. This one is the projection. This light blue line is showing the projection out into the future. And this can be combined with many other model runs. So if we look at other models, they might be representing physics in the climate system slightly differently. When we do that, we get a little bit clearer picture of what the range of responses could be to northeastern United States annual maximum temperature. Keep in mind this blue area here is showing what happens under a lower emissions. So anywhere between, or by the end of the century, our temperature might be anywhere between about 13 degrees Celsius and about 18 degrees Celsius. So it's quite a range. If we look with the higher emission scenario, this one's showing the average of all of those scenarios, we could pinpoint it right around 15.5 degrees. When we throw in the higher emission scenario, we could see that this is substantially higher. There are a few model ensemble members, right? This one down here in particular, which shows maybe not quite as much warming as the other scenarios or other models. But when you combine the two, it's very clear that there is a distinction between which path we take and what the northeastern United States annual temperature response will be. Again, under a lower emission scenario, it's about 15.5 degrees centigrade by the end of the century. That's compared to about 12.5 over our historical period here. As we get out to the end of the century under higher emissions, it doesn't ever really level off. It's still increasing, but the average over 2080 to 2100 is about 18.4 degrees centigrade. And if you were to take a guess, where on Earth do you think, or where on the East Coast do you think currently has an 18.4 degrees centigrade temperature? Well, it's probably closer to a Washington, D.C. climate. If we were to limit our warming to 15.5, a place like New Hampshire might start experiencing a winter climate that's more like New Jersey or so. So you can think of this as southerly locations as being a proxy for our northern winters in the future. When we look at our winter temperature simulations, again, now we're looking at places over here, right? Historically, most of our winters are well below freezing in the northeastern United States. There have been a couple in recent memory that have been above freezing, but for the most part, they're below freezing. As we get out towards the end of the century, under a lower emission scenario, most winters are going to have above freezing temperatures. There might be a few winters that could potentially be below freezing. That's what that dashed line is indicating. But under the higher emission scenario, unlikely that we'll be having winters that are below freezing. So again, this is going to make it such that we have fewer days with snow cover, many more instances of rain instead of snow, and also earlier spring lake ice out and river ice out if it ever ices in at all. Nope, not showing those. So what does this impact on snow? Well, this is what I've been studying spending most of my time studying. From 1980 to 2005, what I have shown here are the number of days in which snow water equivalent is greater than 30 millimeters. If you translate that to assuming a 20% snow density, that's about 6 inches of snow on the ground. For a place where, like I live, right over here, we're looking at around anywhere between a month or 2 months of snow on the ground. That's how greater than 6 inches. Out into the northern parts of our region, it's very clear that we have several months of snow depth that's greater than 6 inches. In the future, however, we could see some big changes. Again, under the lower scenario, we're looking at 1980 to 2005, so this is that same plot I just showed you. In 2010 to 2039, so, well, that includes some of the years that we've seen in recent memory, not too big of a change, but there is a little bit of a shift of the snow line moving north. In 2040 to 2060, still moving north, and by 2070 to 2099, now my neck of the woods is probably seeing less than a month of snow on the ground. If you look under a higher scenario, there are very few regions in the period 2070 to 2099 that have a month of snow. And this could spell a lot of trouble for our northern ecosystems, especially our northern forests in mountainous regions like the Adirondacks, the Green Mountains, and the White Mountains, New Hampshire and Maine. And this is problematic again. Remember, I said that skiing is going to show up quite a bit. We might end up with more winters that start looking like this. This was a photo taken at Sunday River, one of our largest resorts in Maine, on Christmas Day in 2006. We could see that they're making snow up at the top of the mountain. This is a very important adaptation strategy, but it was not quite cold enough to cover the slopes underneath the ski lift that year. If you look at projections in rain to snow transition zones in January and February, we continue on a high emissions pathway. That zone is going to move much farther north. So places in New Hampshire, northern New York, Vermont, and Maine that typically would see much more snow, they're actually going to be much more subject to rain instead. And I've already definitely been seeing this in my neck of the woods. If you're in southern New Hampshire or even in the Boston area, you've probably been noticing that we have not had much snow. We have had our fair share of rain while the mountains have been getting snow, but overall, we're already kind of in this transition zone. In the western US, it's a very similar story. Under a higher emission scenario, we can see that by the end of the century, there is very few regions in the western US that are going to have very deep snowpacks. Anywhere in the 1980 to 2005 range, anywhere they're seeing white, they have about 600 plus millimeters or 60 centimeters of snow that is very deep in those higher elevations. By the end of the century, only the highest of elevations are going to be having that much snow. And I've in 2012, I started investigating this in the context of the winter tourism economy in the United States. It turns out this is a very large industry, generates billions of dollars in economic activity. We recently updated this report in 2018, so if you wanted to check out this one, this was co-produced by Protect Our Winters and Recreational Equipment Inc., also known as REI, and it documents how resorts, how the ski industry responds to warmer winters, and then also what adaptation strategies they've been taking into the future. When we look at the report in detail, we can see that the U.S. ski economy generates about $11.3 billion in economic activity and supports 191,000 jobs. This is really important for many regions, especially places like New Hampshire, where our northern counties are generating about 45% of their visitor spending is coming from the ski industry alone. When they have a really bad winter, that number decreases quite a bit, and that can lead to a lot of problems for people who own restaurants up in the mountain communities or own a hotel. If they have fewer visitors, that means there's fewer dollars coming into their community itself. When we look at direct spending, this is specifically talking about their ski tickets that they buy at the resort, or perhaps if they bought a meal at the resort itself. The indirect spending is the spending that they do within the community itself. So say you go out to dinner or to a restaurant after your ski day, or maybe you stay at a condo that's in town, but not necessarily owned by the resort. We also have the induced spending. And this is kind of, you could think of this as the economic effect that ripples out to the rest of the community. So if you work at a restaurant in a mountain community town, you in turn are buying groceries. You're also maybe sending your child to daycare or taking the bus. This in turn affects your economy. If you have unemployment increasing during those warmer winters, that also means there's less money being spent by their community members as well. We can look at the state at the state level, and what we see is that in Colorado, they lead the nation in terms of jobs supported by the ski industry. This is for 2015-16, so that was a particularly bad year for the Northeastern United States. If you wanted to, you could add a couple thousand to each of those state numbers and get a more accurate picture of what it looks like in a regular year and not a down year. California is our second largest ski economy. They support about 21,000 jobs per year. And overall, if you were to tally up all of these in the Northeastern United States, you'd find that it comes pretty close to what Colorado is supporting. One thing that catches most people by surprise is that there are more skier visits in Pennsylvania than there are in Maine and New Hampshire. A lot of this has to do with the fact that people take day trips from New York City and urban New Jersey and take those trips to Pennsylvania. Question into the future, if Pennsylvania is losing their snow faster than we are, will those folks still make the trip north and spend their money elsewhere in other states? It remains up for grabs, and we're actually not 100% sure, but it's going to be very important to know economically into the future. We can look at the same numbers, but just by their economic activity as well. And where I'm from, the ski industry is generating well over $300 million in a given winter. This was for 2015-16 again. But in a much larger ski economy like Colorado, this is into the billions. We're looking at $2.5 billion in 2015-16 and $1.2 billion in California. When we compare our bottom 5 winters in aggregate across the United States compared to the 2001 to 2016 average, we note that there is about $1 billion less in economic activity and 17,400 fewer jobs. During our top 5 snowiest years, they get buoyed by about $692 million, and there are 11,800 more jobs available. Well, this has a very interesting asymmetry to it, doesn't it? If we look at the bottom 5, right, if you decrease by $1 billion, why wouldn't you in turn increase by $1 billion on the top 5? Well, it turns out a lot of resorts can reach capacity. If you have only so many spaces in the parking lot, or you can only move so many people up the mountain on lifts, you're going to reach an upper limit when you have a really good year. But in a bottom year, that tends to lead to situations where the bottom can really figuratively drop out. And they have some resorts that didn't even open in certain years. One particular example was in Oregon in 2015, where they were in such a bad drought that they could not even make snow to combat the warm winter temperatures. So what are resorts doing? Well, a lot of them are reducing their emissions and increasing energy efficiency. Places like Breckenridge have committed to being 100% renewable and 100% working towards carbon neutral. Many other states in the US, or cities and towns in the US, are also doing this. Burlington, Vermont, for example, is already carbon neutral. And places in New Hampshire, we have about 4 towns right now, including our capital city, Concord, have committed to being 100% carbon neutral, which is really encouraging. And it really shows leadership at the grassroots level to do something about the problem. Resorts are also gotten very good at efficient snowmaking. I talked to a recent general manager at one of our ski resorts here in New Hampshire, and his response whenever someone asks him, how's the skiing been in this warm winter? Like, well, it's way better than it's ever been. And that's a lot due to the fact that they have great snowmaking capabilities now. Many resorts in the Northeastern United States are able to cover 100% of their mountains with snowmaking, even if Mother Nature isn't providing what they really need. It can be hard to keep snow on the mountain. This one is actually from a cross-country race, you'll note, the American Birkie, and they had to cancel the race in 2017 because the trail conditions were too poor due to recent warm weather. One of their most recent capital campaigns is to make sure that they can have snowmaking for this, essentially, one of the biggest cross-country races in North America and ensure that they have safe trail conditions through snowmaking. Resorts are also bringing science to the mountain. This was an event that was held at Arapahoe Basin, and you can see it's quite crowded. This was held up in their conference room on the top floor of the lodge. They weren't exactly sure how many people were going to show up when they held it, so they hedged that it wasn't going to be too popular, but boy, were they wrong, and maybe next time they should consider holding this in the Après Lounge and allow people to really congregate around a really important topic. These are actually scientists from CU Boulder and the National Center for Atmospheric Research describing the research they've been doing in the region on snow. And I have to tell you, it's really not hard to get scientists to get up to a mountain. This was our Climate and Global Dynamics Division at the National Center for Atmospheric Research. And what you're looking at here, every single person in this photo is a climate scientist. Many of us are skiers, I myself and the one in yellow here in a snowboard, but we make sure to spend a day out together enjoying Mother Nature. And if we're up there, well, why not ask us to talk about science? We'd be happy to. Resorts have also gotten really good with snow management. You might have heard stories of resorts in Europe using tarps to cover the snow that they've made the previous summer or the previous winter to keep it over the summer and use it for the next year. There were also instances of trucking in snow for Sochi Olympics and in Vancouver as well. So managing their snow and making sure they have enough snow resources for winter is another adaptation strategy. Also shown here is a strategically placed snow fence to help trap snow, which they can then groom and move about on the slopes to redistribute it. And of course, resorts have, I alluded to this earlier with Pat's Peak, they're expanding their business models. Many of them are hosting weddings and reunions and other events in summer. Many of my friends have done some mud runner events up at mountains, and it's actually quite a great environment to do that. They usually have the facilities, and they tend to have been dormant in the past, but nowadays a lot of resorts are making sure they're being used year-round, and that can be very important to salvaging an otherwise poor season if the summer season kicks up. Lastly, and I feel most importantly, resorts have started getting political. Aspen Snowmass this year launched the Give a Flake campaign, in which they described to their folks, skiers, how to contribute to the solutions to climate change. And most of that is talking to your representatives and congressmen. It's or congresspeople, I should say. Many people just need to pick up the phone and let them know that their winters are important to them. And maybe it's not through the context of skiing itself, but it could also be through snowmobiling or perhaps ice fishing. Or maybe even just the fact that you really like having a snow day once in a while. I know I sure do, and we've not had any so far this year. It's currently mid-January. Our snowstorm is on its way, so they say this weekend. But we have right now 0 inches of snow on the ground in New Hampshire, in coastal New Hampshire, and that makes me pretty sad. But it's not just the ski industry that gets impacted. I'd also mentioned earlier our northern ecosystems, specifically forested ecosystems. This is a very lovely photo that was taken, a single photo was taken each day of the year and then stitched together to create this composite image showing the course of a season in a person's backyard. You can see here the start of snowmelt and then into what I would call mud season in New England, and then getting into the full canopy green up in summer. And this constitutes what's known as the vernal window. This is a period of ecological opportunity. There's a lot of nutrients getting moved around from melting snow and increased solar radiation coming into the canopy. And we define it specifically as the period between snowmelt to canopy closure. Now, we've been investigating this in the northeastern United States. Specifically, Peter Groffman up in Hubbard Brook, New Hampshire, has tracked the last day of snowpack at one of our experimental forests. And shown here, this is very similar to our lake ice out graph. We're looking at the day of the year from January 1st. So again, day 90 is roughly the end of March, and day 120 would be the end of April. And what we see is a decreasing trend. That means that our day of snowpack disappearance has gotten earlier in the year. At the end of the time series, right around the 1950s and 60s, at the end of this linear regression, snowpack disappearance was occurring in around April 22nd. Today, in the 2000s, it's probably closer to April 7th. That's a full 2 weeks less of snowpack that these forested ecosystem has up in northern New Hampshire. We can also look at the other end of the vernal window. right? Sorry, oh, this is the earlier snow melt, lengthening the vernal window on one side. And then if we look at canopy closure, now what we're seeing, again, this is day 90, that'd be March. This would be end of April, getting into the end of May. We see, again, an earlier leaf out date, right, or canopy closure date. So this is when our leaves have finally reached their full size. It usually happened right around Memorial Day, May 28th in the 1950s. Today, it's occurring about a week earlier, right around May 21st. What this means is that we have an overall lengthening of the vernal window, right? Vernal window is the date between snowmelt to canopy closure. The 1950s, it was about this long. The 1960s, it increased by about 8 days. So that's a week longer, potentially, of mud season. And I'm not sure about you all, but mud season is definitely not my favorite season. So what does that longer vernal window mean, right? We have a lengthening on one end, snowmelt occurring earlier, canopy leaf out or canopy closure also occurring slightly earlier, though not as much. This could lead to some phenological mismatches in the timing of energy, carbon, and water related ecosystem processes. So let's walk through a couple of those. Again, I've alluded a little bit to the role of snowpack on energy balance. When you have a very bright white snowpack, it's going to reflect a lot of the sun's energy and help cool the surface. If you have a very dark surface that lacks snowpack, this is one of my field sites in Durham, New Hampshire, you're going to end up with a surface that's absorbing a lot more of the sun's energy and accelerating warming because it turns that energy into heat. When we look at things like carbon, the period between snow-free conditions to budburst, so when the buds actually start to leaf out, not full canopy closure, during the snow-free period, soils can warm up and the microbes that are living in the soil will start respiring organic matter. So respiration is what we all are doing right now, right? We're taking complex sugars and combining them with oxygen that we breathe in. And then when we breathe out, carbon dioxide comes out with a little bit of water, which we can always see, especially in colder conditions, also known as dragon's breath. So what this means is if we have a longer vernal window, that means that we have more CO2 that could potentially come out of our soils during this period. It's not until the canopy bursts, right? Once we have a canopy bud burst and the leaves start coming out and photosynthesizing, they'll start drawing down that CO2. And so a big question is, how much does this impact the annual carbon budget throughout the year? Will we start seeing additional CO2 come into the atmosphere because of the longer vernal window? That's one of the questions that myself and other researchers are trying to ask. We can also look at changes in water. So in a place like New Hampshire, there's not too much of our stream flow that comes from snowpack melt, but it is an important mechanism by which nutrients are delivered to major water bodies. So during our spring freshet, we have a large pulse of nutrients that reach what's known as the Great Bay. This is a coastal estuary that's home to a lot of fish where they lay their eggs, and it acts as a nursery. If we have a timing mismatch between the delivery of nutrients, for example, it happens too early in the year because of an earlier spring melt, well, that means that the fish that are laying their eggs may not be there yet, and they might miss that pulse of nutrients to help foster their next hatchlings for the spring. So what will the vernal window look like in the future? Well, this photo was taken February 26, 2017. Anyone who was in New Hampshire during this time might remember that it wasn't exactly winter-like. This was one of our warmest periods of time that we ever had had in a February. And in Boston, in fact, this was the warmest February day they had ever recorded. Many people were walking around in shorts and t-shirts and enjoying outdoor activities like biking and yoga on the docks instead of enjoying their typical winter activities like building snowmen or snowshoeing. For us, this meant that we saw some really big changes in our field site. That also meant that all of our snowpack disappeared. This instrument right here, well, that was measuring albedo or reflectivity of the snowpack. And you can bet that this surface was absorbing a lot more of the sun's energy than it would have been had it been covered with snow. Now, one thing that most people don't really talk about when we're talking about changes in winter climate is the fact that there's also a psychological effect. And many of you might have been feeling that this year if you're from the New England region, specifically southern New England, or perhaps in a region that's also experiencing a little bit of a different winter this year. The word solastalgia was introduced by Glenn Albrecht in 2003. He's a philosopher, and he combined the meanings from solace, meaning the comfort of home, and nostalgia, the melancholy of homesickness. These are two feelings that, when combined, can make winters just feel weird and wrong. When I have a winter when it's 80 degrees in March or it's 75 degrees in February, it just doesn't feel right. There's no snow. I don't have a warm winter coat on. I'm wearing shorts and a t-shirt, yet the sun angle is very low. It just doesn't feel like home anymore. And I start to miss the winters of my past. Not sure if any of you have ever felt this, but next time you do, remember this word, solastalgia, and you're experiencing the psychological impacts of climate change. We can also ask people what they feel about climate change. I've been working with a sociologist here at University of New Hampshire, Larry Hamilton, and we asked people, 607 people in New Hampshire, did they think that the winters were warmer in the past 20 years compared to 30 to 40 years ago? And I've broken this down by region. So you can see these two regions, right? This green area, this is the Connecticut River Valley, and the North Country, our northern region, where most of our ski resorts are. They seem to have a propensity to say, yeah, in fact, winters are indeed warmer for the past 20 years compared to 30 to 40 years ago. We've also found that amongst those populations, they tend to participate more in winter sports. And we left this open-ended. We said, snowmobiling, ice fishing, skiing, snowshoeing. There was a wide variety of winter sports definition. But most of those folks live in the North Country, and they're also more apt to recognize that winters are warming. So what can you do? I try not to end on too depressing of a note. Solastalgia can be a tough one to swallow, but you guys are already doing a lot of these. You're educating yourselves, and I'll talk a little bit more about defending the science. It's something I certainly do every day. Using your voice to talk about climate change and making sure that you're walking the walk when you are working towards reducing your own carbon emissions. And then the last thing, clearly all of you are doing this, is measuring snow. So let's go through each one. In terms of educating yourself, one of my favorite places to go is climate.nasa.gov. Unfortunately, this website is not available right now due to the government shutdown. So do keep in mind that it will be up again soon, and it's a great place to keep track of what's happening in our environment. There's many other ones, but this one just so happens to be my favorite. You can also defend the science. A famous quote by DeGrasse Tyson was that a skeptic will question claims and then embrace the evidence. However, a denier will question the claims and then reject the evidence. And some of you might have seen this in mainstream media with regard to climate change. One such example, Breitbart News, right? They were known as saying, and this was December 1st in 2017, I believe, they had said that global temperatures plunged and there was icy silence from climate alarmists. The date is important here because this is the graph that accompanied their report. Note here, we're showing monthly temperature starting in 1995, and there's a huge drop from here to here. Well, this is also known as the summer to winter transition. It typically does this every single year. And when you look at the longer term record, right, not starting in 95, but looking at a more climate-based record, climate is typically defined as 30 years or longer, we see something more like this. So there's that drop, and it's showing up right there. Now we're going to expand that time series quite a bit. So going back into the 70s, 60s, now we're getting into the 40s. Is that drop looking very significant now? Probably not. And this might have been why there really wasn't much talk about it from climate scientists, because we focus on the long-term trend. Temperatures on Earth rose about a full degree Celsius over that time period. You should also use your voice. It's time to speak up, and it's time to, if you're comfortable, get political about this. Dr. Catherine Hayhoe is a well-renowned scientist and physicist at the Texas Tech University, and she's famously said, a thermometer is neither Democrat nor Republican. And she makes a good point. Temperature doesn't care what your political affiliation is. It's actually just going to measure temperature. And the facts stand, we know that our temperatures are getting much warmer. When you're talking with other folks about it, it's important to be respectful, and it's important to recognize when you're dealing with someone like a denier. I tend to encounter them probably a bit more than your average everyday person, but it's important to know when to step away and say, you know what, this person's not listening, and I need to move on and talk to someone who is willing to listen. Many of my conversations at Thanksgiving did actually deal with climate. And I was quite surprised to learn how many of my relatives were very, very much aware of the difference between weather and climate. Weather being the short-term variations in everyday atmospheric conditions, and climate being the long-term change. Lastly, or not lastly, but second to lastly, it's very important to walk the walk. We need to work on each individually and as communities to reduce energy and fuel consumption. I was fortunate enough, my landlord installed a new fuel boiler for us, and that helped reduce our emissions quite a bit this year. I also try and take the bus as frequently as I can, which can be a little humorous to students who see their professor on the bus and wonder, why doesn't she have a car? And it's like, well, I do have a car. I just choose to take the bus. It's been a little difficult in recent weeks because we are on a reduced schedule. They tend not to run the buses as frequently when the students aren't here, but you better believe once the buses start running on a regular schedule, I'll be hopping on. And in the summertime, when it gets warm enough, I'll be biking. You can also carbon cap or tax yourself. This requires that you take yourself to a carbon calculator. There's many available. I don't have a single favorite one, but figure out what your emissions are. Estimate them. I know for my footprint, a lot of it has to do with airplane travel. And I've been working to reduce my airline travel. One thing I'm doing right now today is instead of going to an auditorium to give a talk, I'm giving a webinar. None of us had to travel anywhere, really. We just opened up our computers and talked to our colleagues that way. And then lastly, support the low carbon economy. If you know a specific company that is working to reduce its own emissions, support them and let them know that you support that. I make sure that I tell ski resorts that are working to reduce their emissions that I appreciate their efforts and that I look forward to seeing them taking more action. Those kind words can sometimes make a big difference and encourage companies to keep moving in that direction. And then lastly, what you all do is measure snow. A lot of you are doing this in your backyard with the Community Collaborative Rain, Hail, and Snow Network, of course, CoCoRaHS. And we greatly appreciate these because a lot of this information gets assimilated into climate models and weather forecast models to improve forecasts and projections. I myself have used CoCoRaHS data in a number of publications, including one that was led by Dr. Alex Contasta, also at UNH, to investigate changes in the vernal window. So having these CoCoRaHS measurements makes a difference. It helps us understand our environment. If you have a station in your backyard, that is fantastic, but just keep in mind there are other programs that you can use whenever you're out traveling. One of my favorites is actually in the backcountry with the Community SnowObs Network. I've recently become an ambassador for their program. If you happen to be a backcountry skier or snowmobiler or just enjoy walking in the woods in winter, you can also just bring a ruler along with you, or in this case, they have an avalanche probe, and stick it in the ground, and that information gets sent via the App Mountain Hub to a centralized database that scientists and researchers and anyone can use to evaluate snow in a given region. And with that, I'd like to conclude, and I would happily take any questions about winter climate.
Well, thank you, Liz. We really appreciate your talk today. Boy, it brings back some memories. Lake Winnipesaukee, remember spending a lot of childhood days there, and the word dragon's breath, I really never heard called that before, but it's kind of a neat way. It is really kind of what we're doing, blowing the warm air out into that. If you guys have a question out there, this is the time to go ahead and type it in. Please include your name and the state, actually, that you're typing from. We've got Nolan Duskin with us today, our CoCoRaHS founder and director. Nolan, any questions here for Liz? And we'll give Nolan a second to get his mic on.
Hello.
There he is.
Okay. Yeah, I got a couple of questions. Since, Liz, you've spent a lot of time on the snow as a skier and a boarder, and I, on the other hand, having grown up in central Illinois and the flatlands, never really learned to ski. And even though I've been in the Rockies here for 40 plus years, it's not been one of the things I've done very good at or enjoyed. But I love snow. And my question is, the quality of man-made snow versus real snow from a real skier or snowboarder point of view, what do you think?
Well, I have to say, growing up on the East Coast, I am quite familiar with East Coast ice. It can be very, very terrible conditions with natural snowpack. And one thing that ski resorts are really good at is chopping that up and making it into a groomable surface that can be much more appealing than, say, our icy slopes that you get when you don't groom. So in that sense, natural can be better as long as it's managed properly. However, nothing beats a big powder day, and you can't really recreate that man-made yet. I don't know if they're still working towards it in terms of using snow machines to create a powder day, but it's certainly a very rare occasion for me to be able to encounter it on the order of like 18 inches or so. That's my sweet spot. That certainly is not replaceable at this point.
Any others, Nolan?
Actually, I do have another one. What about freezing rain projections? Obviously, that's going to be a tough one to know if the frequency and severity of freezing rain is likely to change over time. But as soon as I heard you talk about Hubbard Brook, we're, of course, working with them on a freezing rain measurement initiative that's going to be showing up here soon in the CoCoRaHS community. And just wondering, what do you think?
Well, it's a relatively rare event to get those big ice storms, right? We do see them roughly every 10 years, maybe at most, in the northeast United States. I would suspect regions to the south of us would probably see a decreased frequency of that, but I'm actually not sure for the future. I believe Catherine Hayhoe has been working with you on that project specifically to develop those projections, so hopefully we'll see a publication that shows that soon, yeah?
Yeah, great. Hey, thanks for taking a shot at that.
Well, we've got a couple questions coming in right now from our observers and listeners out there. Here's one from Robin. Robin wants to know, with a changing climate and associated extremes, are we experiencing climate wind changes? Thus winds more often, winds stronger? If so, wouldn't that keep it cooler? She's wondering.
That's a great question. I've actually not seen any publications on trends in winds. It doesn't mean that they don't exist, but I don't have my finger on the pulse of that body of literature at this point. One thing we are looking at more in our research is the concept of winter weather whiplash. So not just the effects of having a warm spell to a cold spell, but also having events that are outside the realm of a normal season. So for example, we have a phenomenon that we like to call Snowtober here in New Hampshire, when you have snow that falls very early in the season due to a freak storm and lands on the leaves and causes much more damage than a snowstorm that happens in the middle of winter when all the leaves are gone. So those types of events, we're not sure how many of them are going to occur more frequently in the future, but we do know that they have a very big societal impact, especially when you have a very large snowstorm followed by a very rapid melt. Those can be very problematic, and it looks like those are going to become much more common in the future to have those warm events midwinter. Whether or not there's going to be snow on the ground during those big midwinter thaws is also open to scientific research right now.
Thanks, Liz. Here's one for Marjorie, and she wants to know, what is your answer to people who accept that the climate is warming but think it hasn't been proven that humans are responsible? So how would you, what do you say to those folks?
I would say that this kind of falls into the skeptics versus deniers. The evidence from scientists that demonstrates that humans are the cause of climate change is there, and we've provided this evidence. And anyone who's rejecting that evidence is dismissing it. They're denying it. And to me, it's very difficult to change their mind. They tend to be very stuck in that opinion. But it is a fact that humans are in fact affecting climate change. So I think making that distinguish between a skeptic and a dismissive or a denier is very important here.
Okay, Ruth from Texas wants to know, where can I find information on what our future winters might look like? Is there anything out there that shows predictions?
Yes, I highly recommend the National Climate Assessment. This too might not be available due to government shutdown, but when the government opens back up and websites become available, the National Climate Assessment is a great place to look at winter projections. These are very robust documents that have been composed by hundreds of scientists' contributions, and they provide our best estimates of what we can expect, especially for the United States future winters.
And we will ask Liz to give us some of these URLs we can put on our website, and you guys can take a look at those. We'll have those up later this week. Okay, here's a question coming in from Susan in Texas, and she's wondering, It seems that unusual high snowfall in the Northeast the past few years. She's talking 8 feet. Single storm in Buffalo. She's talking about here also the Arapahoe Basin record ski season. Denver getting more snow, still Mother's Day weekend snows and so forth the last couple of years. And so she's wondering those type of things, would they change the forecasts ahead? And again, some of these, these are single events as we look at. I know the Buffalo one is a lake effect snowstorm, very small area affected. But what's your answer to some of these things?
Yeah, so in terms of like what we can expect in terms of these large events, well, they're actually pretty consistent with what we would expect from climate change. Talking about lake effect snow, the 8-foot dump that they got was also a period when they didn't have much ice on the lake, and that was due to warm temperatures. If you don't have a lot of ice on the lake, that leads more moisture to be evaporated to the atmosphere that can then be mixed with cold air above and turned into snow. Same can also happen when you have, say, an atmospheric river that comes off of the Pacific Ocean. If that's a very moisture-laden, rich body of air, and it combines again with cold temperatures, you can have much more snow than you would expect otherwise. And a lot of this has to do with the fact that a warmer atmosphere can hold more moisture. So as long as temperatures are below freezing, we can expect to see more snow. Once things start moving well above the freezing point, however, that's also when we start running into trouble with extreme precipitation events in winter that are not necessarily snow, but rain. And when that rain falls on a frozen soil, that frozen soil can act like concrete. It's highly impermeable, and that leads to excessive runoff and can lead to a really big situation with flooding.
Thanks. Here's one coming in from Diane. Diane wants to know, are there studies that show that deforestation and the increase of asphalt and concrete within cities has also impacted climate change?
Actually, this is a region of research that I'm quite fond of, specifically speaking to deforestation. As many people might know, in the New England region, we cut down about half the trees 150 or 200 years ago. Most of the trees have since regrown, but we do find evidence of deforestation in the form of stone walls. They're quite photogenic when you take photos of them. But we also know that had an impact on climate. When you deforest a landscape, that tends to increase albedo or reflectivity. So we're going back to that whole energy balance question again. When you deforest the landscape specifically in wintertime, if there's snow cover, that open land is going to be much more reflective than the forest that previously stood there. So this is another big impact. In terms of asphalt also tends to give off quite a bit of heat. That tends to increase temperatures in cities as well. But there are some trade-offs with reflectivity. White concrete can be a bit more reflective than, say, blacktop. Yeah.
Thank you. Here's one from Cindy in New York, and Cindy says, has anyone tracked the frequency of significant warm-ups during winter months, such as 2 or 3 days of 50 to 60 degrees in the Northeast, over a period of the last 50 to 60 years? Are these increasing, and do they affect the amount of runoff and length of mud season? Her thinking is that having more runoff earlier might shorten the mud time.
Yeah, so I'm trying to remember, but I feel like I recently read a paper about this exact phenomenon, investigating how winter warm-ups have changed over time. And it was something I read very recently, but I'm failing to pull it into my recent memory now. But I feel like they did say that, yes, indeed, we are seeing more of those 70, 80-degree days midwinter. And that, in turn, is really affecting hydrology, especially if there's already snow on the ground. That snow will melt very rapidly under those conditions, and in some cases sublimate, so go directly from the solid phase into the atmosphere. But over time, we could expect that we'll reach a point where there simply is a lower likelihood of having snow on the ground in the first place, and those warm days are simply going to occur when we really just don't have much of a canopy. And that ties back into our effect on soils, where they start releasing more CO2. If they aren't frozen and it's warm, they're going to start kicking up their respiration and releasing CO2 to the atmosphere.
Thank you. Here's Mary in upstate New York, and she noticed a couple of years ago she started experiencing occasional thunder snows with lightning. I remember living in Maine and seeing those as a kid too. The first happened in January in Vermont, and now, so she's wondering, is that an effect of climate change, starting to see these thunder snows?
I've wondered that myself. I've never had the pleasure of enjoying a thunder snow. It sounds like it's a pretty fascinating and very rare sort of thing that doesn't happen all that often. But anecdotally in the news, I feel like I've been hearing about it more. I wouldn't be surprised if this warmer atmosphere in winter could lead to greater increased frequency of conditions that could lead to things like thunder snow. Mm-hmm.
It sure does get tricky for folks here in Colorado on the ski slopes when we have a little thunder and lightning, especially on the lifts in the springtime. Okay, here's another one here. This is from Phil, and Phil would like to know, would publishing the bloom line over time illustrate how the line has changed in shape and latitude as a function of the local climate change? And then he has a second part of that. It has been said that the Gulf Stream conveyor is changing in the northern latitudes, and it could cause a dramatic change in the north warming months. What is the status of the Gulf Stream conveyor, if you know that? So two questions here.
So the bloom date, I believe bloom line, he's talking about canopy green up. So when does the canopy burst? And they have documented a northward migration of that bloom date. So it's happening earlier in the year, and it's happening across latitudes as well, such that our more southerly latitudes are greening up earlier, and that our northern latitudes in turn are greening up earlier. So this has been tracked by scientists, and there's many folks that are also tracking it with, say, bird behavior. So when are birds migrating north as well? And we're seeing pretty consistent signals between those. It's very evident that our warming atmosphere is having an impact on our ecosystems. As for the change in the Gulf Stream, there is a section of the North Atlantic that has shown a cooling pattern, or not nearly as much warming as other surrounding regions. And that is indicative of lower North Atlantic meridional, what they call meridional overturning. So there's a little bit less heat that's getting transported north into the North Atlantic because the Gulf Stream is slowing a bit. Whether that will manifest into a very large shutdown remains to be seen. I think it's unlikely, but it is going to have some changes in that region, absolutely.
Thanks. Tommy from Virginia just brought up a comment here about Catherine Hayhoe, her doing a great TED Talk recently about climate change. Actually, Nolan and I have had a chance to meet with Catherine, had breakfast with her one time, and she really knows her stuff. So we'll try to post that as well on the website, access to that as also. Okay, here's another one. Sherry from northern lower Michigan, there we go. She said they've been seeing more freezing rain this winter. She was wondering if that trend will continue.
I think to a certain point it will. If we start to reduce emissions, then perhaps you'll see it more frequently. If we don't reduce emissions and things continue to warm, at a certain point, that freezing rain is going to just turn into plain rain. And to me, that's also one of my least favorite conditions. Mud season, when it's 38 and rainy, is probably my least favorite time of year, and that's when I really need to get out of the region because I can no longer tolerate that type of condition. So I think at a certain point, it probably will transition back over to rain, but hopefully we can get our climate change situation under control, and ultimately, I'd rather change it back to snow.
Ray from New York was curious about the questions that we had for folks registering for the webinar. They wanted to know how accurate were the answers. Were folks pretty good with those, or what was if you had a chance to look those over?
I didn't have a chance to look over the answers yet, actually, but I suspect that most people got them right. To go over them, I think the first one, what was the first question? Which is more reflective, snow? Or how reflective was snow? I actually can't remember what I asked.
Yeah, Noah, do you have those offhand? And he may not have them.
Okay.
We'll try to revisit that on the website. We'll put what we'll do is we'll list. So on our CoCoRaHS Weather Talk webinar series website, you'll have a place where you can view this webinar and have the resources there. We'll put down the percentage of folks. We'll put the correct answers to those questions, and then kind of a percentage of how many folks got them right. Well, that'll be coming up again later this week.
Okay. I do know that the one question was whether Northern Hemisphere snow cover extent had decreased, increased, or stayed the same, and those who answered decreased were correct. I showed that slide. Yeah.
Okay. Well, we're gonna wrap it up here for today's talk, and we appreciate everyone being part of it. Again, Liz, thank you for taking time out of your busy day to be with us, and we greatly appreciate that. Well, folks, as we close out our program today, we want to inform you that our next CoCoRaHS Weather Talk webinar is coming up on the second day of spring. That's March 21st. It's a Thursday as well. And we'll have Karen Kosoba with us. She's with the Center for Severe Weather Research. She'll talk about the Doppler radar on wheels. That should be a very interesting talk. Look for an upcoming announcement on our website. Finally, when you're signing off today, please take our brief survey. It'll pop up on the screen. So until next time, this is Henry Regis for the rest of the Colorado Climate Center and the CoCoRaHS team saying goodbye for now and have a great afternoon.